Hi guys. I'm going to do a Skittles example of the Skittles lab because on the tests it was really obvious which partner did the Skittles part and which partners didn't. And there will be a Skittles question on the mastery where you have to, given an initial amount and a data point, you will have to write the correct equation by calculating K. So I'm going to go through and do that with Everett and Jacinta's data because I have their lab here right in front of me. So here we go. We would be given something like an initial amount of Skittles. That is backwards because I'm upside down. So my initial amount of Skittles is, we're going to say 8 Skittles to start. And after 8 rounds, there are 159 Skittles. I'm just going to call it SK so I don't have to write the word Skittles again. So going from this equation, y equals y naught e raised to the kt. This y naught means initial. I-N-I-A-L. That sub-zero is only making this y different from this one. All that it's saying is that these two are different, so I can't combine them. This stands for the initial, so I'm going to use my initial amount of Skittles there, 8. I don't know what K is. That's something that I have to solve for. That's part of the math. And 8, 159 is a data point. 8, 150. Oh, that's it. What's next? 8, 159 is an X, Y data point. Sorry, my X's are kind of looking like T's. This is an X, and that's a Y. This XY data point is going to go in my equation for X and Y, so that the only variable that I have is K. So I'm going to be raising this to the 8K and set it equal to 1, is that a 9? Nope. Sorry, 159. Okay. So the first part of the problem Part 1 is to find K. So I'm going to start doing that by just solving this equation for K as if it were an exponential equation that I was trying to solve a variable for X. I need to isolate my variable term by dividing by 8. So this is times 8, divide by 8. Those are inverse operations. So now I'll do 159 divided by 8. Should be about 20. Okay. 19.875 is equal to e to the 8. Okay. Now, what's happening to my variable is that I'm raising it to a power, right? My variable is in the exponent. I undo exponents by taking the log, and so I want to take the specific log, which is going to undo this base. That log happens to be the natural log. Oh, I got a text message. Okay, so taking the log of both sides, the ln of e are inverse operations of each other, so now on this side I have 8k equals the ln of 19.875. divide by 8, divide by 8. And I'll get that. I'll write it a little bit bigger so you guys can see. The ln of 19 point, over here right now. The ln of 19.875 divided by 8 is equal to k. Make sure that you're closing parentheses here so you don't get a calculator error. You should get that k is approximately, okay, hold on, the ln of that number divided by 8 equals, okay. I got 0.374 because whenever you cut off the decimals, you're rounding. So k is 0.374. My final equation then is going to look like this one. So I'm going to plug in my initial values again. 8 times e raised to the 0.374x. Now, the reason I'm plugging 8 back in is because that initial value doesn't change based on the number of trials or the initial term. This is part of my equation. That's my initial amount. My final equation has to be back in terms of x and y so that I can now express how many Skittles I have in terms of how many trials I've done, or if I know how many Skittles I have, I could solve backwards for what trial number I'm on. So this would be our final answer right here. If the question was, what is the equation?